All right, welcome to This Explainer. Today, we're diving into literally one of the most frustrating universal problems in data engineering right now, AI hallucinations. Look, if you've ever tried to use artificial intelligence to speed up your data pipeline or, write queries for you, you know exactly what I'm talking about. We all want to work faster, right? But dealing with an AI that just randomly makes things up, that often slows us down way more than it helps. So today, we're going to look closely at exactly how we can stop this from happening by grounding our AI agents in absolute truth. We've all asked an LLM to write SQL only for it to invent non-existent column names. Ouch. That hits close to home, doesn't it? It hurts because it's just so true. You ask an AI to be your helpful little assistant, and instead of saving you time, it confidently hallucinates source tables. It throws in columns that have literally never existed in your data warehouse, breaks your entire pipeline, and you end up spending more time debugging its mess than if you'd just written the code from scratch yourself. It is a massive shared pain point for the developer experience everywhere. But this perfectly frames the core of the issue, and more importantly, how we fix it. Think about standard LLM generation. This is basically an AI just guessing your database schemas based on its massive but generalized training data. It's essentially taking a shot in the dark. But then we have a massive paradigm shift, catalog-grounded generation. Instead of a guessing machine, your AI becomes a highly reliable copilot that is strictly bounded by your real metadata. It literally cannot hallucinate because it's only allowed to generate code using the strict facts that you provide it. Which brings us to Section 1, the paradigm shift, introducing dgdmg. Enter dgdmg, which stands for Data Hub Grounded DBT Model Generator. The core promise of this tool is pretty incredible. It takes your standard natural language requests and converts them into validated DBT models. But the secret sauce here, the actual game changer that stops those hallucinations dead in their tracks, is that it uses real Data Hub metadata as its absolute source of truth. The AI isn't allowed to think outside that tightly defined box. Section 2, the core mechanism, the 5-step workflow. Okay, let's dive into this and break down exactly how this AI agent prevents hallucinations from input to output. We can map out this entire guardrail system in a simple 5-step workflow. Step 1, metadata retrieval. Step 2, constrained generation. Step 3, self-correction. Step 4, GitHub PR creation. And finally, Step 5, catalog write-back. When you put these together, these 5 distinct guardrails guarantee that the SQL generated is syntactically accurate and mathematically sound based on your actual real-world data environment. So let's unpack these steps to see the magic happen. Step 1 kicks in before a single line of SQL is even written. Through DataHub's Model Context Protocol, or MCP, the system reaches out and pulls the exact schemas you need. But wait, it goes way deeper than just table names. It extracts the upstream lineage, flags any personally identifiable information, those critical PII warnings, and it even identifies failing data quality assertions. It's gathering all the necessary business context and crucial flags up front. This way, the AI knows exactly what it's dealing with before it starts generating anything. Then we hit Step 2, constrained generation. The system takes that exact, perfect schema it just retrieved and feeds it directly into Grok's insanely fast Llama 3.370B versatile model. But here is the absolute key to the whole thing. It doesn't just hand the schema over as a mild suggestion. It pairs it with incredibly strict instructions to never invent identifiers. The AI is put in a highly constrained environment. It must use the exact table and column names provided by the Data Hub lookup, essentially turning off its ability to guess entirely. Now for Step 3, self-correction, there's a really important number to keep in mind, and that number is 2. Because even with the strictest instructions, AI can occasionally fumble the formatting. So the system acts as its own internal QA tester. It runs post-generation checks on all the code, specifically validating reference and source calls. And here is a pretty wild fact. If it finds an invalid call, the system doesn't just crash and throw an error back to you. No, it auto-repairs itself. It loops back to fix the code up to 2 times before finalizing the output. That is some incredible built-in resilience. Once the code is fully verified and self-corrected, we move right into Steps 4 and 5. The system completes the loop by opening a complete pull request directly in GitHub. This PR contains both your raw .sql file and the accompanying schema.yaml. But, and this is great, it doesn't just throw the code over the wall and forget about it. It actually writes back to DataHub. registering the newly created model into the catalog, and actively adding the new upstream lineage edges. It updates your entire data ecosystem automatically, so your documentation is literally never out of date. So the crucial point is this technical concept of idempotent writebacks. If you are a data engineer, you already know how massive this is. Basically, this means that if you happen to rerun the exact same natural language request, the system will automatically update the Data Hub dataset lineage without creating messy, duplicate edges in your system. It keeps your catalog completely spotless and prevents the massive headache of duplicated metadata when you run things multiple times. And right alongside that feature is fallback safety, which is a non-fatal writeback execution. Let's think about the reality of working with interconnected systems for a second. What happens if your metadata catalog is temporarily down or unreachable the exact second the AI finishes writing the code? Well, because of this resilient design, the GitHub PR generation just continues smoothly anyway. You still get your production-ready code right in your repository, even if the catalog update has to silently fail or just wait for later. Section 3. Under the hood, the tech stack. So, what is powering all this? It's a very modern, punchy stack. On the back end, we have fast API handling the logic, utilizing server-sent events to stream responses super efficiently. The front end is cleanly built with React and styled with Tailwind. The AI brain, as we mentioned earlier, is Grok running the Llama 3.3 70B Versal model, and the glue holding this all perfectly together? That's the Data Hub MCP and the GitHub REST API. It's a remarkably lightweight but incredibly powerful architecture. And honestly, best of all, if you want to get your horns dirty, setting this up for a local run is a total breeze. You just spin up the backend with a standard UVcorn command on port 8000, and the front end with an npm rundev. But here is my favorite feature for testing. It actually comes with a built-in mock e-commerce catalog right out of the box, featuring tiered bronze, silver, and gold data layers. Meaning, you don't even need to connect a live Data Hub instance to test this thing out. You can literally see these anti-hallucination guardrails in action on your local machine today. Finally, Section 4, the payoff, and the future of data agents. Throughout this explainer, we've broken down exactly how bounding an LLM to real metadata completely eliminates the hallucination problem that has broken so many pipelines. So I want to leave you with a provocative question to think about. If your AI agent is now constrained by absolute truth, what are you going to build next? Seriously, when you no longer have to constantly worry about an LLM making up column names or inventing phantom tables, when you finally have a copilot that produces reliable, ecosystem-aware code, the boundaries of what you can automate just blow wide open. I highly encourage you to think about how you can implement these catalog-grounded guardrails into your own data engineering workflows to reclaim your time. Thank you so much for joining me for this explainer, and happy building.